Okay, it's 11 o'clock, and I'll get started in, let me be sure my phone is no rings. I'll get started now.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning. This is Steve Cantrell. This is the first session in February for DBA Fundamentals. Today we have Erin Stellato presenting, answering the question, what happened with Query Store? This should be a great one because this is the biggest thing to come out on 2016 as far as I'm concerned, and I'm really looking forward to it. I told Erin earlier, since we just recently moved a production server to 2016. Anyway, I've got a few other things to go over. Our sponsor, who helps us with our giveaways, SentryOne, has lots of freebies also. You can go and download a professional version of Plan Explorer. That's fantastic for working with query plans. There's free tuning advice. They have plenty of other educational and product videos just like ours, and they have, you can send in questions and ask about performance. So this will be recorded, obviously, and you can go back and look at these links if you need to, or just basically Google SentryOne. They actually, let me explain the giveaway we have. For January, February, and March, everybody that attends one of our sessions will be put in a drawing to win a $350 Amazon gift card. Because we have two areas, it's easier for us to do it that way. We'll be doing the same thing April, May, and June. So attend our sessions in Down Under with our Down Under contingent, and also here. They also, I forgot to mention these. This is something I wanted to put in. They have some really great, and there's Erin on some of these books. They have some really good books that has some really good information. These are not little 10 or 15 page things, but you can get them free at SentryOne. That's one of the first things I downloaded. I think Brent had something about great free downloads, and that was in it. So definitely check that out. PASS has multiple virtual chapters, lots, over about every topic and with just about every language. So try that out. Go to sequelpass.org/VC and look up all of the free education that we have. Pretty soon, we haven't got the exact details yet, the look of the PASS sessions will be changing for the local and virtual groups. They're supposedly revamping and making it look a lot better. Here's our sessions that are coming up. Today's with Erin, partitioning basics, Lego, treating your tables like Legos. That's Down Under. SQL, Saturday Night SQL has one coming up, Why Your Data Type Choices Matter. We'll be doing one with Kimberly Tripp 2 weeks from now, stored procedure optimization techniques, and Paul Randall, index fragmentation, internals analysis and solutions. That should be fantastic. Well, you can go look at our website, and we'll send you out an email usually once or twice a month, maybe 3 times a month, giving you the ability to sign up. Here's 2 other sessions that are coming up pretty soon that I thought looked pretty good: detecting, repairing, and preparing for corruption with Ryan Adams and the HA and DR site, and the Women in Technology site has a real good one, Moving Past Imposter Syndrome, Wendy Pastrick. There's the links for our sessions. You can pick up our scripts, slides, and session material. And if you go to our YouTube channel, you can subscribe there and get that. Oh, and for everybody that has came in through just YouTube and don't come in through PASS, okay, somebody's saying that my screen is not showing up. want to see the title slide. Okay. Now it is. Okay. I don't know why it wasn't. I thought I had it selected, so sorry about that. This will be recorded, so you can go back and look at it. It's my normal stuff that I go through. So, but for the people that come in through YouTube and don't come in through Pass, sign up, because this way you can come to live sessions and ask questions. That's worth a fortune to be able to do that and ask detailed questions from some of the best people in the business. Okay, today, well, one other thing, volunteering. That's something that everybody needs to try to work with and try to do at least one time in their life with Pass, just to keep the ball rolling for everybody. Mine simply is helping with this virtual chapter. It's really not that difficult to do. There's other things you can do, and you can go to Pass and look up different things for volunteering, and they have tons of different ways you can help. SQL Saturdays are another form of great free education. I think, Erin, you had one up in Cleveland just recently. I think that was just a week or so ago. But
it was just 3 days ago.
Yeah, and you probably presented at that. Anyway,
I did.
These are great. These are like mini conferences that are free. Normally you pay for your lunch. That's about all. And vendors help pay for everything. So these are great free sessions to come to, and you can go to SQLsaturday.com and see if there's anything close to you. These are just some that are coming up in the near future. And volunteering. Volunteer with Pass. Okay. I'm going to turn this over as I'm talking about Erin's presentation. I'm going to turn it over to her. But Erin works with SQL Skills, and you're in for a treat if you've never heard Erin before, because she's one of the best people I know of that can take a real complex topic and break it down and make it very understandable. That's one of the reasons she works with SQL Skills and Paul and Kimberly, that's one of the best groups in the business. So she's been an MVP. She lives in Cleveland, and she has over 15 years of technology experience. She focuses on statistics, performance tuning, extended events, and helping accidental involuntary DBAs figure out how SQL Server works. She's great at doing these beginning sessions, and that's one of the reasons we try to have her at least once a year. Today she's going to be talking about Query Store. This is one of the most anticipated and talked about new functions with 2016. I'm not going to go into it in detail. She's going to give that to you in just a few minutes. I'm turning it over to you, Narian.
Thank you, sir. Can you make me the presenter so that I can share? There we go.
Here you go.
Perfect.
Okay.
Perfect. All right. Well, thank you for that introduction, and hello, everyone. Wherever you are, I hope that it is not raining, because it is raining here in Cleveland, and I've had enough. But that's okay. This will put me in a happy place, because I love talking about Query Store. So we're going to jump through a couple slides real quick, just information about me. The most important thing on this slide is my email address. It's there in the middle, erin@sqlskills.com. If you have questions about this particular session, then feel free to email me. Information about me, I work for SQL Skills, which, if you're not familiar with our company, it's owned by Paul Randall and Kimberly Tripp, and they are married, if you don't know that. And then none of the rest of us are married to each other. Glenn Berry, Jonathan Cahias, Tim Radney. We provide training through our immersion events. Those are kicking off, actually coming up at the end of April. We've got online training through Pluralsight. We also provide consulting. So we do health checks, performance tuning, help with upgrades, and if you're looking at 2016, I'm all about that right now. We provide remote DBA services. We present at conferences, and if you want to hear from us more, there's a link at the bottom to join our Insider. newsletter. Here's some information about our classes. Again, if you just hit our training page, you'll see information about those, and we've got a current discount for new clients. If you're interested in a health audit, definitely reach out. This is one of my favorite parts of any session. I get to give out Paul's email address, paul@sqlskills.com. You could probably guess it once you know mine. But if you send him an email and mention that you attended the DBAFundamentals user group for this session, and you've never had a free code to Pluralsight before, he will send that to you. And actually, this course, or this session that I'm giving today, is expanded out on Pluralsight. That just came out last month. So if you really want to dive even deeper into Query Store, there's a course out there on Pluralsight. We've got 50 of them at this point. Here's the abstract for this session. I'm not going to read it because I'm assuming you're here because you've already read it and it's of interest to you. So this is what we're going to do today. We're going to talk about Query Store so that you can understand what it is. We're going to see how you enable it and see how you find information, and hopefully we'll have time to talk about how you force a plan. So actually, before, I'm going to launch a poll here, which I've never done, so I'm very excited about these. So there's a poll on here. There we go. Which you should be able to see now. I want to know if you're running SQL Server 2016 in the production environment. And as you're answering that, I also want you to think about, what do you do all day? And you're like, really? And I'm like, yes, really. I want to know what you do all day. And this is just a conversation that you're having in your head, because obviously you can't shout out answers in a room. But whether you're a DBA or a developer or a software administrator or anything else, I want you to think about what your typical day is like. Are you in meetings all day? Are you sitting in front of the computer fighting fires all day? Are you creating new content? Right? What does your typical day look like? And as part of that day, what tools do you use? And some of these tools you may use more than others. Right? Perfmon. Perfmon is a tool that I have used since I started working with computers, and I still use it. It's in every single computer that I touch. Is in terms of a Windows computer. Right now that we can run SQL Server on Linux, that's a whole other story. But there's a lot of great information from Perfmon. And I've got the DMVs, and I've got DBCC commands. And if you're running 2012 or higher, hopefully you're using extended events. Otherwise, you might be using trace. And you've got query plans and xperf. All of this information is something that you're using either to gather information about what's going on in SQL Server because you're troubleshooting, because you just want to understand what's going on in your environment. But very often, right, you're fighting a fire. You're trying to solve some kind of a problem. And when you're trying to solve those problems, one of the most useful things that you can have is baseline data. And I've talked a lot about baseline data before. And the challenge there is that you either have to roll your own, which takes time and effort, or you can get a third-party tool to do that, which makes it a lot easier, but there's a cost associated with it, a different cost than if you roll your own. And so up until Query Store, that information wasn't being kept natively for us by SQL Server. So Query Store has this feature in that it keeps information about queries for us without us having to do anything other than enabling it. So you might have heard it called a flight data recorder for SQL Server. And it captures information about the queries that you execute, about the plans that are used for those queries, and about the runtime statistics for those queries. So how long did it take to run? How many logical IOs did it have? How many physical IOs? What did it use in terms of CPU? Query Store captures all of that and stores it and makes it available to you. Oh, thank you. Here, let's close that. There we go. Okay, so you want to see my first slide. Sorry about that. Here we go. So the poll, just so you know, about 75% of you are not using SQL Server 2016. About 25% of the users here, or the attendees here, are using SQL Server 2016. So that's a little bit higher, actually, than I saw over the weekend at SQL Saturday. So that's kind of cool that it's getting adopted. So if you're on 2016, my next question that I wanted to know is whether or not you're using Query Store. So if you are, I can't do another poll at this point, but that's okay. So let's go back to Query Store. It's capturing information about the queries, the plans, and the runtime statistics. And one of my favorite things is that it's available in all editions of SQL Server. So you don't have to have Enterprise, right? It's there no matter what. If you're running Standard Edition or you're running Express Edition, which hopefully you're not running Express Edition in production, but if you're running either of those editions, make sure that you're running Service Pack 1. There's a bug related to Query Store cleanup prior to SP1, so I really want to make sure that you're running that version. If you're using Azure, Query Store is in there. Query Store has been in Azure way longer actually than it's been in the box product. So make sure that you're using Service Pack 1. There's a lot of other reasons to use Service Pack 1, just as an aside. Now, some information about Query Store. It is enabled at the database level. So this is a per database setting. This is something you're going to use for your user databases. You can enable it if you're interested for MSDB. You can't enable it for master, for tempDB, or for model. Interestingly enough, the default settings for Query Store come from model. So just like the default recovery model for a new database comes from model, or any other settings pull from that database, it's the same for Query Store. And you can go and change them, and I've got a blog post about that. But when you enable this, you enable this per user database, so you can enable it on more than one database on an instance or just one. And it stores all this information that I've mentioned in internal tables that are inside that user database, which means it's stored in the database, which means that if I back up the database and I restore it, that Query Store data goes with it. It persists between restarts. The data is in a table, just like any other data you put in a table. Now, in order to see that Query Store data, you need to have the view database state, not view database stats, that's a typo I need to fix, but view database state in order to view that data. And you need to have DB owner in order to force and unforce the plans. And DB owner is a pretty big privilege, but being able to force a particular plan for a query is a pretty big privilege as well. So only DB owner can do that. And then you can view the data within Management Studio for Query Store, but you can also view this through T-SQL. So you've got a lot of flexibility in how you look at this information. So if you don't like what the UI is showing you, you can roll your own query, which is pretty cool. So at this point, I think it's really cool to get into a demo to actually see what Query Store looks like. So I'm switching over to a demo. And if you can't see that, then let me know. But within Management Studio, I've opened this up, and I have, underneath my databases, I have the Wide World Importers database. So I'm using the latest and greatest demo database available for 2016. And you'll see that within Wide World Importers, I have Query Store. Now, if we expand AdventureWorks, I have it as well. If we expand the system database in MSDB, you'll see that there's no Query Store here. Okay, so Query Store, this panel shows up here because I've enabled it for this database. And when I expand this, I have 5 different views that I can dig into. One of the things to note is that if you're running the production version of Management Studio, remember Management Studio is now in a separate release cycle than SQL Server as a whole. So the current Management Studio only has 4 views. It doesn't have this 5th one. I am running the version of Management Studio that you should not be running in a production environment, just so you know. So the first thing that I want to show you is regressed queries, right? Very often, as an administrator, you're fighting a fire, right? Someone comes to you and says, performance is tanked, things are going bad, what's going on? And you're like, okay, let me see what's running. So this view gives us the regressed queries, and initially we come in here and you're thinking, well, that's not very impressive. Well, it's not, but I need to change my configuration view here because you'll notice that right now I'm looking at the last hour. Well, let's look at maybe like the last 15 minutes and see if that gives us any more data. And it gives us a little bit, and this view right here, which is a graph view, and right now I only have 1 bar in my graph, is not very interesting. What I prefer to do is look at this grid view. So I'm going to click on this grid view, and here in this grid view I can see the queries that are running. Now this is a VM, right? This is a virtual machine with a very specific workload. So in a production environment you're going to see a lot more than what I'm seeing here. But what this is, this view, it gives me the top 25 regressed queries in the last 15 minutes. So regressed meaning we've had a change in performance. And I really like this view because I can see what the stored procedure is if it's associated with the stored procedure. I can see the query text. And as I scroll over, you can see that I get some information about additional duration workload, and I get additional logical reads. I get additional physical reads. And if I scroll all the way over about execution count, and I get the information about the number of plans, which is kind of cool. So I've highlighted this query here, and on the right I've got a plan, and it shows me the plan down here in the bottom of the screen. And then if I click on this purple icon, I have a different plan. So for this specific query, I've got two different plans, and the performance of these two different plans could be very different, right? And one of them could have been the plan that was sitting in cache, and it was performing great, and then for some reason it got kicked out, and a different plan came in, and maybe it doesn't perform so well. So Query Store allows us to find this information, and we can do this in the UI. I mentioned that we can do this in the UI, but we can also do it in T-SQL. So I can look at a lot of the same information here. Now did I force my, this is a good one. It's specific, remember I said to the user database, so I was in master, nothing showed up. I select wide world importers, and I run this, and now I see my information. So now I've got some of the same information that I saw before. I've got the actual query, if it's associated with a particular object, stored procedure. I've got the plan, which I can click on and open up and take a look at. And I've also got additional execution statistics. Remember I said that it'll tell us how many to run, when did it last run. I've got compile information as well. All of this is being captured in Query Store. So if I want to find queries and plans, because maybe those are queries I need to be looking at more detail because there's not a lot of stability, right? There's a lot of variation in how they execute. I can use this query to find that. Okay, so that's just a quick look at Query Store. Let me see where I am with questions. So what do I mean by force a plan and undo? I'm going to get to forcing plans, but if I come back here, right, for this specific query, I have a plan that has an index seek, and then it has a key lookup, and I have a plan that has a clustered index scan. And by the way, when I'm in here, if I click on this plan ID and then I hold down my shift key and I click on this other one, I then have this really cool little icon that says compare the plans. So if I click on that, you'll see I get the two plans right on top of each other, and now, and on the bottom over here I get the properties, and so I can do a comparison of these plans. And so maybe I decide that this index seek with the key lookup is the plan that I really want to use, that I really want this query to use, so I can force it. I can say, see this little force plan right there? And I'm going to come back to this later, but I can tell SQL Server, I want this query to use this particular plan. So the next question I had, can I grant the Query Store view to developers application support who have limited access to the database? They need the view database state permission in order to do that. That's the permission that they need in order to access those Query Store views. The data is stored in internal tables. The views are on top of those internal tables. The view database state gives them permission to that. To run the T-SQL queries that I'm running, they need view database, or they need the database state privilege. They don't need DB owner. DB owner is only needed for this plan forcing. Okay? All right. I'm going to hop back over to my slides. So I mentioned earlier that we have the plan store and that we have the runtime stat store. So when you execute a query, right, every time you execute a query against SQL Server creates a plan. Most of the time, that plan is stored in cache. There's exceptions, but most of the time it's stored in cache. And if it's stored in cache, then it can be reused, right? That's great. The plan store, when you execute a query, takes the query that you've run and the plan that was used, and it stores that into Query Store. And then after the query finishes executing, it takes information about the execution time, the duration, the CPU, logical reads, writes. It stores that in Query Store as well. So the text in the plan we call part of the plan store. The other information we call the runtime stat store, right? Information about the execution of the queries. Now, pictorially, what we see. This is a picture from MSDN, and if you're not familiar with plan caching and how all of this works, that's okay. What I wanted to show you here, let's see if I can get my Zoom it to work. It's on the other screen. That's fantastic. So no, we're not going to worry about that. So what happens is we have query come in, right? I'm running a query to select information against the Wide World Importers database. There's a check to see in the plan cache, does this plan already exist in cache? And if it does, then we're going to use it. If it doesn't, then we're going to go through compilation and optimization. And at this point, whether it pulls a plan from cache or whether it does compilation and optimization, it sends that plan and that text over to query store. That happens. And at the same time, there's a check for recompilation, and then, which is really not needed here, and then there's an execution of the query. Once the query finishes executing, then you can see down here it sends the execution stats over to query store. So this is kind of the order of events, how the query store activity fits into normal compilation and optimization. Now, when you set up query store, there's a few settings that are important to understand. The first is turning it on, right, our operation mode. The second is related to what queries we capture. Do we capture all of them, or do we filter out the ones that are considered insignificant? You can specify how many plans you keep per query. The default is 200, and heaven help you if you've got more than 200 different plans for a query. I have yet to see a case where I've needed to up that number. The max storage size, an MB, this is how much space am I allocating in the user database for the query store data. So remember, it sits in your user database. So of the space that I've allocated in the primary file group, mind you, that's where the data is going to go, the query store data. My cleanup policy means after how many days should I start cleaning up old data. If you have any third-party tool, or even if you're rolling your own in terms of baselines, right, there's a process that kicks in to clean up data that gets old. So how long do I want to keep that data? Do I want to keep query information for 30 days, 60 days, 90 days? Understand that the longer you keep that information, the more space you're going to need for it. So the cleanup policy is something that you're probably going to want to tweak over time. Right? Do I really need 6 months worth of query data? Probably not. My size-based cleanup mode means that as I get to the max, do I want SQL Server to come in and start to clean up data for me? Which could mean, if I didn't set my max storage size high enough, it could mean that it's cleaning up data before it hits that cleanup policy. So let's say I set my cleanup policy for 60 days, and I set my max storage size for 2 gigs. And after 30 days, that size-based cleanup mode kicks in. So there's a balance here between that storage size, that cleanup policy, and that size-based cleanup that you're going to have to pay attention to. I then have my data flush interval per second. Now this is how frequently am I going to push data to those query store tables, because one thing that I didn't really say is that this query store data, even though it lives on disk, it temporarily resides in memory. And this is a performance enhancement by the SQL Server team. Think of how often your queries are executing, right? How many batch requests per second do you have? If SQL Server was trying to flush those execution stats out to disk for every single query execution, the system would be overloaded. So it's optimized to store that information in memory before it gets pushed out to disk. So the data flush interval seconds determines how often is it going to push that out to disk. And it's done asynchronously, right, so that it doesn't slow down performance in general. And you can change that. And the last setting we've got here is the interval length in minutes. And the interval length is, remember I said back here, right, that we're sending execution statistics about how long it took for the query to run, how much I/O did it use. But in the query stats store, or the query store, it's not storing information about each individual execution. It's doing an aggregate, and it's giving you aggregate information, and it's aggregating across a window of time, because you wouldn't want to look to see that a query executed 10,000 times in an hour and look at the individual run times for every single hour. What you're interested in is your average, your min, your max. So that's what's stored in Query Store, and that aggregation window is defined by the interval length in minutes. So, and I'm going to show you this in the demo. You can see that you've got different values that you can set. So let's hop back in so that we can look at this live. I had one question. Let's see. How am I seeing the Query Store queries within the Solution Explorer window? Well, I have a solution for this demo, which has all these queries over here, and these are the queries that I've written. So I think that's what you're asking. All right. So another question. Are there default Query Store settings that should be changed? I'm going to go through those. Thanks, Bill. And then, does the Query Store data persist between server restarts? Absolutely, because where is the Query Store data stored? I'm giving you a pause to think about the answer, right? The Query Store data is stored in tables in the user database. So absolutely, the Query Store data is going to persist because it's stored. Now, what you may be asking, Jacob, is that if data is sitting in memory, and you're telling me it's getting flushed out to disk every so often, what happens on a restart? Well, on a controlled restart, right, like on a controlled shutdown, that data should be flushed from memory to the Query Store tables. But if you have a system crash and it doesn't have that chance to do it, then you could lose that Query Store data. So those runtime stats that were sitting in memory that didn't get flushed to disk, you could lose that. But the Query Store data as a whole absolutely persists between restarts. All right, we're going to create a separate database for testing. I'm not going to mess with my Wide World Importers database. So this is a movies database that we're going to create just for fun. And we're going to create a table and add some data. And the schema of the table and the data really isn't that important. We're just going to add this in here. So at this point, if I come back in here and I refresh, right, here's my movies database. Pay no attention to that archive database. And if I expand the movies database, you will see that underneath this, I do not have Query Store anywhere. Remember that I did for Wide World Importers. So Query Store only shows up when I have Query Store enabled. So how do I enable it? Well, I can go into the properties. And once this opens up, I'm going to grab some water. It is not on the options page. It is down here, right? It has a whole new page called Query Store. And right now it's off. It's off by default when you create a new database, unless for some reason you've changed something in model, which I would not recommend. I would turn this on as a decision. I wouldn't expect Query Store to be enabled for every new database. So what we do is you can turn it to read-write, right, which basically turns it on. These are the default settings right here. And then I can go ahead and click OK, and Query Store is enabled. So to understand what happens in terms of the UI, this is what happens if you script it out. And now if I scripted it just from that window, this is all you get, which means that it's setting all of those default settings that, again, it pulls from model. So it turns Query Store on, it sets the operation mode to read-write. What it's really setting, right, based on those values that we saw, it is setting it to read-write. It sets the cleanup policy to 30 days. It sets the data flush to 900 seconds. The interval length minutes to 60, so that's that aggregate for runtime stats. Max storage size of a whopping 100 megs. Query capture mode, all size-based cleanup auto, max plans per query, 200. So now let's talk about what I might change in here. So my operation mode, read-write, obviously I want this to be read-write because I want to collect information. If it's a read-only, then it's not collecting data at all. My cleanup policy, I kind of discussed this already, right? Default is 30 days. How long do you want to keep that data in the Query Store? I think 30 days is a good start. It used to be 367 back in the initial release. 30 is a better starting point. If you're still troubleshooting queries that have executed 30 days ago, okay. But if you're maybe using that for baseline information, that I would understand. Again, how much space you need is going to be affected by this setting here, that cleanup policy. The data flush interval seconds. How frequently am I pushing that information out to disk? The default is 900, which is 15 minutes. I have it set to 60 here. I don't recommend that, actually. I would probably set it to something like 300, right? Maybe set it to every 5 minutes. Understanding that if the server crashes 4 minutes and 58 seconds after it last pushed data to disk, I might lose 4 minutes and 58 seconds of query store data. I'll take that. I might even take 15 minutes. I don't know that I want to take an hour, okay? So if you want to tweak this, I would start maybe at 15 minutes and then set it down. What's the effect on performance? Well, I'm flushing data out to disk, so I'm pushing data to be written, just like if I'm adding data to my database, right? This is normal database functionality in the background, folks. So if I am increasing how frequently it pushes the query store data out to the query store tables, then it's just like I'm adding more data to tables in my database. My interval length. Now, I set this to 1, which is actually pretty ridiculous. This is the interval across which that query store data is aggregated. Something probably like 15 is good, maybe even 5 if I want something to be really granular. You have to use one of the following values. You don't get to play here. So you can pick 1, 5, 10, 15, 30, or 60, or 1440, which is 24 hours. I don't think that you want that, right? But the smaller this number is, the finer that granularity is. And if I'm keeping more intervals of data, this also means I'm keeping more data. So again, if I am going to lower this interval, then I need to make sure I have enough space, which brings us to our max storage size. That default is 100, which is really low. I've set it here to 512. You're asking me, some of you have asked me this already, what size should this be? How much space do I need to allocate to query store? And you know what my answer is going to be if you've heard me give any presentation before, right? It depends on what? My answer isn't just it depends, right? I want you to think about what it depends on. So it depends on some of the things I've already mentioned. It depends on this interval length. It depends upon this cleanup policy. But it really depends on your workload, right? Yes, Yehalem, you're correct. It depends on my workload, right? So if I run a lot of stored procedures that are running the same stored procedures running over and over again, and maybe I only have 100 batch requests per second, the different queries that are actually executing is pretty low. But if I run ad hoc queries, right, where users can input different values, where maybe they can change the sort order, where maybe they can add different columns to a query or take away, right, that really increases the size because query store stores every query, and it's a literal, it's a textual matching that occurs. So running a stored procedure, right, it's the exact same query that runs over and over. So the query text doesn't change. But when I run an ad hoc query where I say where product ID equals 1, that's a query. Where product ID equals 2, that's a query. Product ID equals 3, that's a query. Those different queries stored separately within query store. So this is very workload dependent. And then I've got query capture mode. All. Do I want to capture all queries or only the relevant ones? All is the default. I recommend leaving it that. You might think, I don't care about my infrequent queries. I don't care about insignificant compile and execution duration. Here's the thing. I know that there are times when people are not seeing queries in query store because they've set query capture mode to auto. The challenge here is that these thresholds for determining what's insignificant are internally determined. You can't configure those. And there's no really specific documentation. So I, for the time being, would leave these as all. All right, size-based cleanup mode on. Do I want query store to go in and clean up the query store as it gets close to that max storage size? The default's on, and I would leave it on. And this is something you're going to have to monitor, because if I don't turn it on, then when this max storage size is hit, then query store will flip into a read-only state, okay? I want the size-based cleanup mode so that query store always runs in a read-write mode and it's collecting data. Now, I could get notified when it flips into a read-only state and all of that, but this is where you've got to figure out a balance of, right, what do I have in terms of space? What do I have in terms of cleanup? How long am I keeping data? Last setting, max plans per query, again, defaults to 200. I think this is a pretty good value at which to leave it. So a couple questions here before I keep hopping on with this demo. Any impact to the transaction log once I turn this on? Well, I'm adding workload, right? So I have to write data. It has to be logged, just like it would for writing to regular tables. What do I not have selected here? I'm not going to worry about that. We'll just leave this as this. So yes, it's probably going to increase activity in my database. It's going to increase transaction log use. Definitely something to pay attention to. Is this going to slow down database performance? Potentially. The factors that are in play here are things like your interval and your data flush interval seconds, right? If I have this really, really low, then data has to be flushed out to disk more and more frequently. Depending upon what my workload looks like, that could create contention in some way. So there's some amount of understanding what happens internally that you need to understand, but in general, it's been optimized so that it's not going to introduce a performance problem. Remember that things show up in Azure before they show up in the box, so Query Store has been used in Azure well long before it appeared here in the box version. So there are thousands of customers that are using it that haven't had a performance impact. Let's see. Any reason why Query Store should not be used? Not that I've thought of. Is there any impact on TempDB? The data is stored specific to the user database, so none that I have seen. I'm just reading a question. So the mirroring or replica will rerun the transaction. This is an interesting question, and I think what you're saying is, what happens if I have a database that's mirrored, or I have a database that's in an availability group? What happens with that query store data? Again, that query store data is in the user database. It's just in internal tables, but it is on the mirrored database. It is in the replica. It exists. So if I have a transaction that inserts data into my query store tables, absolutely that transaction occurs on the mirror or on the replica. The query store data goes with the database. Okay, now I'm going to scroll on down. So let me check here in our movies database what we have set, and this is a view sys database query store options. So let's see what we've got right here. So we're read write. That's what the state is. This is what I want it to be. So one of the things that you're looking for that you could monitor for is when this flips, when the actual state flips to read only. How much size is currently being used? What do I have set for the max? I set it to a whopping 100, which was the default. Data flush interval 900, which is 15 minutes. My interval length is 60 minutes, excuse me. Stale threshold 30 days auto. So these are all the defaults in here. Now, let's run a query. So we're going to run a query against our movies database. And if I start to look in the system views, right, we've got a few of them that we end up pulling together. And this first one is just query information. So every single query comes in here, and this view gives us, right, remember compilation occurred at the beginning of that process. It gives a query ID and a text ID, an object ID, and compilation information. Now if I look at that along with query store query text, now you see I get the actual text for the query. So every query has a query text ID, and that gets associated to a query ID. And then we have a handle for that query. And then we start to pull all of that plan store data together when we add in query store plan. So understand here that I have different plans and I have a query ID which gets associated back here. So I can have a plan with a query and I can have a plan that has the same query ID, right? So you can see plan ID 1, plan ID 6, they're both associated with query ID of 1. Okay, that's the case where I had two different plans for the same query. Now let's change this so that I'm looking in my movies database. I'm going to see slightly different information here. Right, but same thing. Here I've got my plans, here I've got my queries, and I've got my query IDs up here. All right, and then the last view that I have is this runtime stats. Remember I talked about my execution statistics, my runtime statistics? So those are tied to the plan. So here's information about the plan. When did it first execute? When did it last execute? And then I've got duration information, right? Average, last, min, and max. Standard deviation, way more than I got in DMExec query stats. CPU information, logical reads information. It goes on and on and on. Everything you want to know about the execution at stats. So if I pull this all together, which I was doing in that first demo, right, then we can see, okay, let's see what my query looks like in terms of what's executed. Let me see the text of the query. Let me see the plan for the query. And if we scroll on down here, let's see. This is a horrible way, by the way, to look for information, right? I'm just doing a wide open select, right? But here's the select that I ran. I can click here. I can see that that's the query that, or that's the plan for that query when it executed. Now let's come back here. Oh, let's stop this. I don't need that running in the background. Now I mentioned the textual matching earlier, and I want to show you an example of this. So I have three different queries which are really the same, but SQL Server doesn't see them as such. This one has movie name proper case. This one has movie name in all lowercase. This one has a bunch of spaces before movie name. So if I run these three queries, right, I get the same results for every single one. But when I look at the output, and this time I'm paring it down a bit, I have three different entries in here. I have three different query IDs. I have three different plans, because each of these is recognized as a different query, even though you and I know that they're exactly the same. So if this is the type of query that you have in your environment, where maybe not in terms of casing or spacing, but you've got different literal values that come into play, you can get a definite increase in the volume of data in the query store. Also note that individual queries are captured. So I have this procedure and it has two queries in it, right? We have a select from movie info and we have a select from actors and cast, because I want to see information about who was in a particular movie. So if I run that, and then I'm going to execute that twice. We're going to execute that once for Tom Hanks and once for Sandra Bullock. And if I look at the output here, and I'm again refining this output so I just see information related to that stored procedure, I have two different queries here. I have query ID 44 and I have query ID 40. And I've got, even though they're within the same procedure, I have them, there are two different queries. So that's really important to understand in query store, that those get stored separately. Note that if I run this from the context of another database, it's still logged in query store. So if I change my context to master, but I execute the store procedure with three-part naming, and then I look at my query store information again, right, my count executions went up. Now, some of you are looking at this and you're thinking, wait a second, why does she have two rows for query ID 44 for plan ID 44? The count execution total is the same. And this is because some of this data has been persisted to disk and some of it still resides in memory. And there's a way that you can write your query to aggregate it across both. I didn't do that because sometimes this scenario shows up and I like to use it as an example. If this happens to you, don't think that there's a problem with your query or that there's a problem with your data. It's because this interval that I've set up, some of the data still persists is on disk, some of it is still sitting there in memory. So not anything to panic about. Now, if I turn query store off, say you get somebody who comes in here and says, I don't know what this is. I don't think we need it. I'm going to turn it off. Are you lost? You're not. Everything still stays in the views. So when you turn query store off, it just means that it's no longer running. It's no longer collecting information. I can turn it back on, and everything will still be there, and it will start collecting again. I do have a way to clear the query store data out. I'll come back to that. Now, before I drop this, let me see what I have. Will the entire query be shown, or will it be truncated? The entire query is in there. It's truncating in my case because I am not expanding the whole thing. So I don't even need it to be back on. Let's come back in here. Do I have the query text? I do. If we scroll all the way over and I expand it, there we go, all that lovely goodness. The operation mode on a read-only replica is forced to be read-only. So let me come back. Remember when I mentioned that if I have a database that's mirrored or I have a database that's in an availability group, this query store data goes over to the mirror copy or over to the replica. And if I'm in an availability group with 3 replicas, this query store data is on all 3 replicas. That query store data is from that primary database. Many of you know that with that replica, I can query the replica, right? I can have a read-only replica that I can run queries against. This is a great thing about availability groups. I can offload those awful reporting queries somewhere else. Right now in Query Store, when I run those queries against that read-only replica, that information doesn't go into Query Store. Query Store is only working for the primary. Okay, so even though I'm running queries against a secondary copy, that information does not get into Query Store. Is that something that we'd like to see? Absolutely. Is it there yet? No. Okay, I'm going to move on because I think I've hit most of those questions. There's a question related to extended events, which I'll come back to if there's time. All right, I'm understanding that the audio is going off and on frequently. I'm sorry about that. I'm not 100% sure why. I'll have to look into that one. Steve and I can maybe do a test later. Hopefully, if I talk slower, maybe that will help. I'm not sure. But we've got 8 minutes left, and I'm going to use every single one of those 8 minutes. So if you have somewhere to be at 1, I completely get it. Remember, this is being recorded. But now I want to talk about plan forcing. So when you have a bad query, not a bad query, it's not like it's a bad person, right? But a query that's not performing well, what can you do? Well, you can change your code, right? Or the schema, which I will always tell you that tuning is your first step always. Sometimes what you may try to do is get what's called the best plan in cache. These jobs are out there. I know I've seen them. I'm not going to call any of you out specifically, but maybe you've got a job that runs and it clears a particular set of plans out of cache for a query, and then it runs that query again with the parameter that you like so that it puts that plan into cache, right? I've seen that. You can use something called a plan guide, and now in 2016, you have the ability to force a plan, a specific plan in Query Store. So let's see what that looks like. Thanks, Chris, for that tip. Okay, so with Query Store, what you can do, and we've seen this already, is that you can find a query that has multiple plans, and you can force one specific plan for that query. It's very easy to do. I'm going to show you how to do that. What you cannot do, which you can do with a plan guide, is that you can't add a hint to a query to make it behave a certain way. Because adding a hint, adding anything changes the text, right? Remember I said there's textual matching in effect. So when I add a hint, that creates a new query and a new query ID in Query Store. But forcing plans is sometimes in the case where you don't have the ability to change the code or add an index, it's an option. So we're going to flip over to my demo for this. All right. I've already got Query Store enabled, but I'm just going to make sure that it's set how I want. So I'm running this. If I could run it correctly, that would be great. And I'm going to clear out old data. So this is the one where you go, because alter database set query store clear means that I've gotten rid of all of my query store data. Turning query store off, I already showed you, keeps the query store data there. Set query store clear means that I've deleted it entirely. Now, quiz. What if this happens to you? What if you've got 30 or 60 days of query store data and someone comes along and runs this statement? What do you do? Well, remember that the data is in user tables, which means that when you back up the database, the data gets backed up. So I could restore from backup and I could hack those system tables, which is not supported, but you can do it, and I could pull the data back that way. There's some caveats with that. You're probably not going to take the data and push it in the database, but know that you could still see the data through a restored backup. Okay, so let's do the unthinkable. We'll clear out all of that data. I'm going to create a stored procedure that we're going to use. The details of this are not huge other than we input a stock item ID and it has 2 queries. So we'll go ahead and run this. And then we're going to run this stored procedure a couple times. And I have a recompile here, not something that I recommend, but I have a recompile because I know that when I run it with these 2 different values, it gives me 2 different plans. And I want you to see those different plans. So we're going to run that. And when I look at the output here, I've got query 1 and query 2, and then I've got query 1 and query 2. So with query 1 up here, I've got this index scan with a filter, and when I look at query 1 down here, you'll see I just have a clustered index seek. So I have 2 different queries, 2 different plans for query 1. For query 2, I've got an index scan and a filter, and an index scan with my compute scalar and a hash match. And down here, I have the same. So I've got the same plan for query 2, but I have 2 different ones for query 1. Now I'm going to add some data, and this happens during the day, right? Probably not in this lovely big insert, but you have changes, right, to your data during the day. And so when that data changes, sometimes what can happen is your statistics change, and when your statistics change, meaning your statistics get updated, then your queries can recompile, and sometimes they get different plans. So now, before, where we had this scan and this seek, notice now we have this index seek with this key lookup and a nested loop before our hash match, and we still have this index scan and a filter down here. And our second query, actually, this plan is now different than it was before. We have this same index seek with the key lookup and our nested loop and a compute scalar before this hash match. So now for query 1, we should have at least 3 different plans, and for query 2, we should have 2 different plans. So what do I see in query store? This is where I'm going to go use the UI. We'll expand this out. I'm going to look at my regressed queries, and again, I'm going to change my configure so that I'm looking in the last, let's say, 5 minutes, and I want to look at the grid view. This is much more useful to me. So here's this stored procedure, and I can sort, by the way, in here, right? I can sort based on the object name, any of these columns. This is incredibly useful in here sometimes. So here's one query. I have 3 different plans. Here's the other. I've got 2 different plans. So let's say that these queries, this stored procedure executes a lot. Let's say there's a lot of data that gets inserted into these tables, and so I get some volatility in these plans, and I find over time that one of these is a better plan. Let's say it's this one. This one's uglier, right? It's not as pretty, but in terms of, let's say, duration, it's less. Now, by the way, I haven't played with this at all, right? Again, this is a 1-hour session just as an intro to query store. I think at this point I could probably talk about it for 4 hours. I don't know. I haven't tried yet, but if I look at logical reads, I can say, oh, this one looks better in terms of plans, right, than that other one. So the other one might have been faster, but this one had less logical I/O. What about in terms of CPU? Well, this one looks better in terms of CPU. So maybe I decide that for this specific query, this plan is the one that I want to use. Now, in the old days, I could try to force this plan in there, again, by clearing the cache of all plans for this query and then running the query with the right value again. But I can now force this plan. And this is so easy, my mom could do it, right? I click on it and I say force plan. Do I want to force plan 4 for query 2? I do. This means that every time this query gets executed, it's going to try and use this specific plan. It's going to do its best. Now, I could do the same thing here. Let's say that I want to force plan 8 for query 3. I could, again, do this in the UI, or I can come back here, right? So it was query 3, right? Plan 8, correct? And I'm horrible at remembering numbers. Plan ID 8, query 3. Plan ID 8, query 3. Perfect. So I can also force this way. Okay? Now, this is a good idea to use in terms of change control, right? It's really easy to do this through the UI, but in terms of knowing when someone forced a specific plan for a specific query, change control, which I know you guys are all using, is your best friend. This is that new view that you're probably not going to have if you're running the supported version of Management Studio. This is the one you're not supposed to use in production, so I can see this option, which is really cool. I can see which queries have forced plans. It shows me right here. I can unforce it from here. If for some reason this is no longer the ideal plan, I can change that. But let's hop back. Now, if I rerun these stored procedures again, I'm doing the with recompile. I was doing that because I wanted the different plans. Now I'm going to take those away. But what I should see is that same plan for this specific query. So here I should expect to see the nested loop. And in this one, I should see my index C. What did I force here? Yeah, my index C key lookup. So let's see what we get when I actually run it. Execute, look at the plan. There we go. I get my nested loop in that first query, and my second one is my seek with the lookup and then the hash match. So I have effectively said to SQL Server, when you run this query, that's what I want it to use. Now, how do I know that it's using that? Well, I can look at the plan. I can look at the XML, and what I look for in the XML, is this, use plan equal true. That's the only way I know for certain that this plan is a forced plan. Now, I am at 102, which means I'm supposed to stop. So hang on, let me see what I have for questions. First is, have I ever seen anyone dump the table out of production, meaning the query store data out of production, to another database to hold old query store data? Have I seen that personally? No, but I've heard people talk about it. Can you do it? It's not supported, but technically yes, you have to use the DAC to access the internal tables. Ratna asks, what about parameter sniffing related plans? Well, this here is a parameter sensitive plan, right? You notice that I get different queries for this stored procedure when I input different IDs. So this query is one that's sensitive to the input values. So I have forced a specific plan for that query. Steve, are you going to cut me off?
No. Actually, keep going.
All right. Those of you
go over.
Okay, so I apologize to those of you that have to go. For those of you that are still here, thank you. I'm going to keep going for a little bit. So how long does a force plan stay in effect, Josh? It stays in effect until I unforce it. Now, what I want to point out here, actually, here, I want to point out something, then I'm going to come back to that. So what happens if I run an individual query, right? That was a stored procedure query. What happens if I run a query that has a literal value? So this one, if I can unclick, has a value of 220. This one has a value of 130. I'm going to run both of these. I'm going to get two different plans, right? Two different plans for two different values. Okay. So in Query Store, I'm going to see that same thing as well. Let's go back to my regressed queries. Let me refresh this. Here are those two queries that I just ran. They're two different queries. So could I force a plan for this query? I could. But because I use literal values, it's only going to be in effect when someone runs that exact same query. So there's no way to force there's no way to force plans for this type of query because there are literal values. Now, I've got other query hints. and I'm going to leave this for you to test, but these other things that I add on to the query change the query text, right? So adding an optimize for unknown changes the text of the query. You may not be able to do that. Trying to make it parameterized, right, declaring a variable and then passing in the variable, changes the query text as well. So I can't do that for queries that have literal values. That's a restriction that's in play there. So does my forcing for a plan persist after restart? Yes. That information about forcing is stored in Query Store. Query Store is internal tables. It persists between restarts. After a cleanup period, it's not going to age out anything that is forced, or it's not going to age out forced queries. So the question, one of the questions that I want to clarify is about this parameter sensitivity. So imagine that this is my stored procedure, and Ratna, I want to make sure that I answer this. Imagine that this is my stored procedure, and the input parameters, 90, 224, 221, 225, 226, 228, 91, 92, those are different values that get passed in over time, right? Because users don't execute it with the same value. Bob executes it one way, Susie executes it with a different value. That's normal. When I force the plan, that plan, SQL Server tries to use that plan regardless of what input value is used. That's the whole thing. Right? That's how we can try to achieve some plan stability when we don't have the ability to tune. So when you don't have the ability to change indexes, when you don't have ability to change the stored procedure code, and that's the stored procedure you're stuck with, when you find a plan that works pretty well for most variations of the query, right? Here's the stored. If one particular plan works well 90% of the time for this query, then that's a plan that you can force. That's one of the benefits of Query Store. Now, Mark asks a question. What if I force a plan and the index that's used in that plan is dropped? Great question. It can't obviously use that plan, right? So Query Store won't fail, right? Your query won't fail. Query Store is not going to let it fail. It's going to go through the your query is going to go through the normal optimization process. So let me go back to the slides actually and see if I can. Execution, plan cache lookup. Let's say that it finds the plan in cache, right? And it's going to use that. In here, there is a check to see if the plan is forced. And if it is forced, then it's going to try and use it. But if it can't use it because the index doesn't exist, then it's going to go through normal compilation and optimization. So if your forced plan can't be used for some reason, like you've changed an index, then it will go through normal compilation and optimization. So what if I have a forced plan with a key lookup and I add a new index that would get rid of the key lookup? Will the plan stay forced? Yes, because as long as the index that you used, as long as whatever you had that supported that query, that forced plan is still there, yes, you'd have to unforce the plan and then reforce it with the new index. All right, I'm going to flip forward in my slides. Other considerations, following up on what Mark asked about. In all cases, SQL Server wants your query to execute. Therefore, it may not use the force plan, because if it tried, it would completely fail because you've changed the index because the index isn't there. And you really need to be careful when changing object names and when dropping and recreating, right? Don't change the index names. And here's the kicker at the end. Notice this for all of you lovely developers out there. Use alter when you're changing your stored procedure. Because when you drop a stored procedure and then create it, because you've changed the code in it, that changes the object ID. And what you may or may not have noticed when we were looking at Query Store is that in Query Store, let's see, is it in this one? There's an object ID. It's tied to the object name, which is tied to that force plan. So when I change the object ID because I did a drop and a recreate on a stored procedure, then I've lost that forced plan. So that's absolutely something that you have to be paying attention to if you are using plan forcing. Let's see, I'm going to skip that for the moment. So I've talked about like a tiny percentage of what you can do with Query Store. You can also do it for these things, right? You can use Query Store to troubleshoot query performance, to find issues related to maxed out, memory grants, figure out what queries use the most resources. You can do testing for an upgrade, right? There's no excuse, honestly, at this point to not do testing, because you can take your 2016 database, which has query store data in it, and back it up and restore it, and then whatever change is made, whether it's new hardware, whether it's a code change, whether it's something else, you can run that same workload against that restored copy of the database and then do comparisons. That means you can also test changes in the cardinality estimator, and you can look at your workloads proactively so that you can reduce the time that you spend fighting fires, hopefully. All right, so we talked about what query store is, how to enable it, how to find information, and we just touched upon how to force plans. The session that I did at SQL Saturday Cleveland last weekend was all about forcing plans, so I've got a whole nother hour if you want to talk about that. There's a couple connect items up here in case you're interested, and again, out on Pluralsight, I just released a course specific to query store. So if you've never used Pluralsight before, you can email Paul, ask him for a code, and you can go ahead and watch that course. Thank you guys for staying late. I appreciate it. I know this probably ran into some of your lunch hours, but thanks for your time, and if you've got questions, let me know.
Thanks, Erin. Thanks, Erin. You pointed out that this session is recorded, and also if they use that Pluralsight code, they could go take the entire course and get all of that extra, which I intend to do. I already have Pluralsight. I love it, but I'm definitely going to go through that course. Thanks. Let's see. One quick announcement. We're looking for someone to help us out with social media. We try our best, but we're just kind of so-so with it. But if you have any inclination in doing volunteer work, give me a shout at my email, steve.cantrell22@gmail.com, and talk to us about it, and we'll consider it. We basically want somebody to help expand our reach better than we do, and so we're just looking for that. This is your chance to volunteer with us. Thanks, Erin, and really appreciate SQL Skills and everything they do for us, and we, like I said, we hope to have you back again next year. Thanks, and bye.